Greetings, everyone. Let's go over the homeworks on 2.2. That was separate equations. And so a separate equation, remember, is an equation that where you can write everything, all the terms with y on one side and all the terms with x on the other side. So it's typically something like you have an expression of y times y prime. Of course, there's also the y prime always, right? And then here, terms that contain x. That's how this looks like. It often, you get it in a form that is not exactly like this, like the one number 6, but you can easily make it do that by cross-multiplying. So let's do that. So we get y prime over y squared minus 1 to the power 3/2 equals 1 over x squared. Okay? The x squares have to go to the right, and y squared minus 1 over 3/2 goes to the left. And now we have it separated. And then it is more instructive to write it with, okay, let's leave it for now in the denominator. At some point I'm going to probably have to put it in the numerator with the negative exponent, equals dx over x squared. Well, here let me do that already. So x to the minus 2. And now we have the antiderive. Now the first, let's do the right hand side, is the easiest one, that's just the power rule. Plus a constant. We were looking for the general solution, so we write here plus a constant. What about the other side? Now, okay, that is a trickier integral, obviously, and the moment you have these weirder exponents, like 3/2, there are not really much methods that deal with that. Trig substitution does with square roots, but this is not even that. Although actually in this case trig substitution would also work, but it's a much simpler one. I told you first one always to go look for is substitution. And the reason is because we have this inside the denominator, but even more inside the denominator, inside the power we have y squared minus 1, and immediately you recognize that the derivative of that is this y on top up to a constant. So we do. So to do this, we do substitution. W is equal to y squared minus 1. Then dw is 2y dy. Remember the steps of substitution. And we have a y dy here. We want to match this. That's one way. I do it this way. You might have learned a different way. So that's what I'm doing here. And now I can plug everything in. So this is equal to, well, the y dy that I just said is dw over 2. And then the y squared minus 1 becomes a w to the power 3/2. But since I'm going to have to integrate, I'm going to write it now with a negative exponent. Great. And this is, again, power rule. It's a half. You add 1 to the exponent, minus 3/2 plus 1 is minus a half. And then divide by that half, minus a half. So the halves cancel out, and we find that this is actually, oh, that's not what I want to do, that this is actually minus 1 over radical omega. W, right? I hope I don't go too quick here. The minus, the halves cancel. Let me do that at least there. And then the negative exponent becomes in the denominator, and the half becomes a radical. And that is equal to, what do we have here? Minus 1 over x plus c. Now, here is something I like to do, is I don't like negative signs, so I can get rid of them by just multiplying everything with making them all pluses. And then what do I do with this one? Okay, technically I have to write a minus c here, but I'm going to rename my constant. So that is something that we often do. So I'm saying with a new constant that I'm, for laziness, also going to write as c, I get this equation. Okay. But if you write minus c, of course, it makes no difference. Okay, so here we go. Well, w is something, right? W is y squared minus 1. So it is 1 over radical y squared minus 1 equals 1 over x plus c. So this is what we call an implicit equation, implicit form. But we really would like, if we can, to get an explicit form for y. And that is not impossible here. It again requires a little bit of algebra. The first thing you want to do is cross multiply. I mean, you have to solve for y here, right? So if I cross multiply, I get this here is radical y squared minus 1. I don't like the denominator in here, so to get rid of this denominator here, what I'm going to do is multiply everything with x on the top and the bottom. That doesn't change my fraction, but it gets rid of the denominator there. So I get x, these x's cancel, 1 plus cx, and that is equal to radical y squared minus 1. Now, of course, I want to get rid of the radical, so I'm going to square both sides. And now I need to solve for y, so I do the plus 1 on both sides, right? So plus 1 plus 1. So then we get y squared equals x over 1 plus cx squared plus 1. Okay, and now finally I need to find y, and y is the radical of this thing. Positive or negative, right? And that, of course, depends on the initial value problem, if there is one. If there is none, then we don't bother by this. Okay, that's the general solution here. I didn't pay attention to it, and I'm not going to do this, but there are sometimes special solutions that are not of this particular form. They are of this form, but they are of this form if you take c equal to infinity. I don't want to say too much about it, so let's just leave it like that. This is the general solution, the solution that we want to. These other solutions, in this case, I forget now, let me see. Yeah, they are just a constant plus and minus 1. Which is why, you remember when I said by taking c to put in infinity, then if this would be infinity, this whole thing would be 0, right? And you get y is plus and minus 1. And these are indeed solutions. The constant function y is a solution to this thing. You can plug that in and verify, and same for minus 1. But these are exceptional solutions that nobody's ever interested in, so I don't want to even spend time on that. Okay, that is the first question, and then the second question. Sorry, I got now. That was number 23. Number 23. X plus 1 times x minus 2 y prime plus y equals 0, and y1 is negative 3. This is an initial condition problem. Again, it's not exactly in the form, but it is clear how to do that. First of all, we bring the y to the other side, so we get the minus y and minus y here. And then, or perhaps the other way around. No, this is how I have to do it, okay. So let's do the steps here, otherwise we get confused. X minus 2, y prime equals minus y. Okay, now I cross multiply. I like to keep my y prime on the left. So this y prime over y, or with the minus sign here, that's being the minus 2. And then on the other side we get this rational function. Okay, so this is dy over y, with the minus sign, don't forget the minus sign. And this is dx, x plus 1, x minus 2. Now this is, I hope that you recognize this is a partial fraction, so we have to do the partial fraction. Yeah, this one, of course, is easy. This is minus ln y. But this one is a partial fraction. And so what we need is the partial fraction decomposition of this 1 x plus 1, x minus 2. We have to write it as, we know that it exists in this form, but we don't know yet what a and b are. And to do that, we clear the denominators. So clear denominators means I'm going to multiply everything with this common denominator. This is, be careful, these are simple steps, but sometimes people get confused or too quick in this step. So take your time here to solve this. The x plus 1 and x plus 1 cancel. And here the x minus 2 cancel. This is sometimes where people get the wrong, x minus 2 here, sorry. see that's, I didn't give myself enough space, and then that is what happens. X minus 2, and then here the x minus 2 cancels, so we have an x plus 1 left. Okay, and to find a and b, the easiest way is plug in roots. Here we have enough roots. Sometimes you don't have enough roots, and then there are other techniques, but let's not consider this problem here. X is 2. That means that, of course, the first term is, well, if I plug in x equals 2 to the left, nothing happens there, but in the right, the first term disappears, and I get 3b. So I see that b is 1/3. And if I plug in the root x equals -1, that's the other root, right? Then now the second term disappears, and I get here minus 3a. So a is minus 1/3. So where are we? This is equal to the integral of minus 1/3 x plus 1. Yeah, be sure that I put it on the top of the right one. Okay, plus 1/3 x minus 2 dx. Great. All these are also ln's. This is minus 1/3 ln x plus 1 plus 1/3 ln x minus 2 plus a constant. Remember, we're trying to solve the general solution here. In this particular case, it's the general solution that we look for. That's why we keep writing the C here, or perhaps let me call it K, but perhaps at some point I'm going to change its name later. Now, this is something that you have to solve here, and this is an implicit equation. So we kind of are there, but we should want an explicit equation. And so that means that we have to, first of all, combine these ln's here. Because the ln's can be combined, these two can be combined in one single ln. First of all, these coefficients here, these factors, they become exponents, and then this becomes a product or a quotient depending on the sign. Okay, so let's do this. That is minus ln x plus 1 to the power 1/3 plus ln x minus 2 to the power 1/3 plus k. And now we combine this. The negative sign means that we're going to divide here. So we get x minus 2 to the power 1/3, x plus 1 to the power 1/3, but I can combine the power 1/3. I hope that is okay. If you don't do that, that's fine. That's not a big deal here. And plus k. Okay, so now I can have a minus ln y here. Okay, let's keep that. So now I can take the exponentiation. Then that would be e to the minus ln y. That would be 1 over y. I hope that is clear, right? E and ln cancel out, but we have this negative sign, right? That means reciprocal. And here we would have e to the k plus this whole ln. Let's not copy it. But that quickly becomes e to the k times e to the ln, and the e and the ln cancel out. So this becomes x minus 2 over x plus 1 to the power 1/3. So we can call this c. So c is equal to, c equals to x minus 2, x plus 1, 1/3. And we are almost there now. We just have to take reciprocals of both sides. So y is equal to 1 over c. Okay, so let me call this still aek here, because I'm going to take reciprocals, then get x plus 1 over x minus 2 to the power 1/3. I just take reciprocal here. You could have with a negative exponent there and then leave it. And then we have to take the reciprocal of this, and that I'm going to call c. Okay, so here I renamed my constant, so c is actually e to the minus k, but that's just a constant. Okay, that's the general form. That's the general solution, but there is an initial condition, and the initial condition is y1 is -3. So the initial condition, if x is 1, then y is 3 or -3? -3. So okay, we plug everything in here. -3 equals c. 2 over minus 1 to the power 1/3. Yep. Okay, that's fine. And so it's a bit ugly. Let's take the, I have to solve for c here. Okay, so what is c? C is equal to minus 3 divided by minus 2, this is minus 2, right? To the power 1/3, whatever that number is. I don't know why they didn't take a little bit nicer number here, but okay, that's the number. That's the solution. In the solution, they combine it a little bit by putting some part of the minus 2 inside and other parts not. That's not really important. So if you give me this as a solution, minus 3 over, the minuses cancel, right? So yeah, you might say, well, what about a minus and a root, because that's a cube root, right? So this is minus 3, this is minus 2 cube root, the cube root, and then the minus here. But the minus of a cube root is the same as the cube roots. The minus is not a problem. It's for square roots is the problem, because square roots the square root of a negative number is a complex number. But here we have dealing with a cube root, so that is not a problem. And so this minus sign comes out and cancels with the minus sign on top. So this is what we have, the constant. So this constant is 3 over cube root of 2. We don't need to rationalize and all that. That's not necessary. X plus 1 over x minus 2, 1/3. I told you I'm not so much interested in simplifications. All right. So that's our homework for separating variables. No, sorry, for separate equations. The separating variables will be for